Okay, it looks like it's 4:45, so we'll go ahead and get started. My name is Kevin Rushforth. I'm from Oracle. I work on both JavaFX, other client technologies, and the Java Packager. So I'll be telling you a little bit about the Java Packager. Also, for any of you who are attending the main session, there's another Java Packager talk, a 60-minute session on Thursday. So this is what I'm going to be covering today. I'm going to motivate why we need jpackage, what it is, what it does, what some of its features are. And then I'll go over several example command line usages of different ways to use jpackage. And I'll have some demos. Right now I'm only going to show them on the Windows machine in the interest of time, but it runs on Mac, Linux, and Windows, which I'll go over later. And then talk a little bit about where we are and where we're going. So first of all, jpackage is a developer-based tool, and it's meant to take a Java application that's already been built as one or more jar files or JMod files. In the case of a modular application, you can build it as either modular jars or JMods. And then it will take your application, it will take the Java runtime, and it will create an installable bundle from that, a package that is specific to your machine and that integrates with the native OS in ways that currently you can't do without using some other third-party tool. As I mentioned, it's supported on Linux, Mac, and Windows. And one of the things that we want to do, and I'll show you some examples of using a command line, a desktop shortcut, but it also will allow you to do some other interactions, native integrations that I'll talk about. And we're defining this with a JEP. So JEP 243 is under review right now. We hope to be able to move it to the next stage pretty soon, which I'll get into. So first of all, why do we need it? What problem is it we're trying to solve? So one of the ways people used to deliver applications, and in fact still do in some cases, is assume there's a JRE already on the machine. In the days when we were actively and aggressively working with OEMs, pushing JDKs and JREs onto every end user machine, that was a reasonable way to do it. So the end user or platform vendor, in some cases the OEM vendor like Dell or HP, would install a JRE, and then we would have an auto-update mechanism to keep that up to date with security fixes. That was the primary reason we had the auto-update. It also allowed you to get occasionally you'd backport some bug fixes or new platform support, like when a new version of Linux or macOS comes out, we often have to make fixes for that. But the primary reason was security. What it allowed application vendors to do, and this was a big win, who remembers the slogan, write once, run anywhere? Well, yeah, write once, run anywhere for a long time also meant write once and deploy anywhere, so that you could take this single platform-independent jar file, pop it on your website, and run it either as an applet or as a Java Web Start application. However, as of JDK 11, and really before that in the case of applets, the deployment stack is gone. We have no longer a shared auto-updatable Java runtime. So what we do is we give a JDK still, but we're not going to have you install that, register it with the Windows registry, or put it in the Mac in the Internet plugins area, and then automatically update it every quarter. Also, more and more applications, especially on mobile, but even now on the desktop, are going to more of an app store model, where you bundle and build the same, or your application that contains everything, self-contained application. And so in that model, jpackage works with that to bundle the runtime and your application. And it runs jlink if needed. And then developers also are able to run jlink. So as I mentioned, it runs jlink. Jlink by itself provides part of what's needed for this. Because one of the questions we would get, especially early on, is, well, why not just add one or two little tweaks to jlink and then you have everything you need, right? Well, almost. Jlink does provide an important thing, which it will allow you to create the custom Java runtime. You can exclude modules that are already there in the system. You can include third-party modules. You can include, if you want to, your own modular application. But at the end of the day, what you have is a directory with a bunch of files. And that's not really an installable package. Further, it doesn't integrate with the native OS. It's not going to put a shortcut on your desktop. It's not going to put an entry into your Windows Start menu. So today, as I mentioned, users will use a variety of third-party tools, or we used to distribute with JDK 8 and up through and including JDK 10, a program called Java Packager. But that was not part of OpenJDK. So only if you got Oracle's distribution of the JDK would that be there. And it was delivered as part of JavaFX at the time, even though it was generalized to be not the JavaFX packager, which is what it started out as, but the Java packager. It was not part of OpenJDK builds because JavaFX wasn't. And when it was removed from the Oracle JDK builds, it being, JavaFX in this case, then so was Java Packager. And so what we've been looking at is how do we then take the sort of generic parts of the Java Packager and turn it into something that we could put as part of the JDK. So our intent is to make this part of OpenJDK so that anybody's builds of the JDK will include jpackage. So it's based on Java Packager, but it's removing all the things that were either specific to JavaFX or specific to the deployment technology stack that we can't rely on anymore. Also, we had to, just in the interest of making it something that we could be pretty sure wasn't going to change and get out in what we hope is still a reasonable time frame, we excluded a couple of features that Java Packager had that we want to add back in. So the features, typically it's used to bundle either desktop applications, which is where it got its start, but also it can be used to bundle command line applications. It supports, first of all, it creates the application image, which is essentially your runtime, the modules you need, your application, any data files your application needs, and some configuration files that say how to run it. And it creates that into a directory called an application image, and then it takes that and generates the native package, which is either an RPM or Debian file, depending on which flavor of Linux you have. On Windows, you can generate an MSI bundle or an exe installer, and on Mac, you do a DMG or a PKG installer. So the main thing that is used, as I mentioned earlier, is to package up your applications that will integrate well into your native desktop environment. So you can set file association so that when you double-click a .xyz file, it launches your XYZ program and other things like that. It'll create desktop shortcuts, launchers in menu groups, and then you can specify update rules for Linux in RPM and Debian files. You can also create multiple launchers, so it will allow you to, if you have one application with either multiple entry points or the same entry point but multiple sets of arguments, you can easily tell it to create multiple launchers and it will create it as a single bundle, but you'll get two icons on your desktop for a desktop shortcut or two entries in the start menu if you want. It requires native packaging applications, which varies from just a couple of additional packages on Linux to Xcode command line tools on Mac and a third-party, endorsed by Microsoft, third-party Wix tool set to allow you to build the MSI installers on Windows. Some of the things it doesn't do is it doesn't solve the how to get the platform installer down to the user. Now that we don't have a generic web start mechanism anymore, and more importantly, we don't have the expectation that every end user machine has Java already installed, then it's up to the application vendor to put and host that application on their website and have users click on it to download it. Also, the one thing that is a little unfortunate, that I know we've heard from other users, but it doesn't handle the cross-platform deployment. So it used to be you could take this jar file, and if all you used were Java calls and you had no customization that was different for Mac, Windows, and Linux, you could just have a single jar file, put it on your website, and anybody could run it regardless of platform. Now you have to do what you would do for other software that you install, and you have to have a Mac version, a Windows version, and a Linux version, and then a little JavaScript code or whatever your website does to choose and download the right one based on the user's platform. Also, as I mentioned earlier, you have to have the third-party tools or the developer tools installed on your machine. Because we use those native developer tools, you have to have a Mac to build a DMG and so on. And there's no support for JNLP files if you were used to doing that, although we are going to provide a sample or demo program called JNLP Converter that will help you do that. It'll basically take your JNLP file and your jar files and it'll run jpackage. And at least in a lot of cases, it will produce what you need. And in the cases it doesn't, it'll give you a good head start. So now what I want to do is go over some example use cases. I'm actually going to run these after I've shown slides for all of them. But I want to spend a little bit of time on this one because this highlights most of the command line options that are available. So the first thing you'll note is I have some of the slides will have things highlighted in red. Those are the ones that are platform dependent. So for example, the package type, the first option. You don't need to specify that if you're happy with the default. It turns out on Windows, exe is the default, so that's optional. But if you're on Mac and you want a PKG file, but DMG is the installer, then you'd have to specify it. And so in this case, we specified that explicitly we want an exe installer. We specified the name, a description, the vendor of this software, and the application version. And those version numbers, depending on other options that you specify, will be used for update rules. So for example, you can have it automatically remove newer or older versions when a newer version is installed, which is what a lot of application vendors will want to do. And then we specify where to find the input files. In this case, our standard non-modular jar file is in the input directory. We tell it where to put the output. And we give it the main jar file. So if you have multiple jars in there, you have to tell it which one is your main jar. In this case, we didn't specify the main class because our jar happens to have a manifest entry that tells it where the entry point is. And then finally, we specified Java options, which in this case, these are arguments that will be passed to the Java launcher when you open the program, when you either double-click it or run the .exe that gets installed. It will specify // and then that argument. Apter is something that's known, $apter is known by jpackage, and it will expand to wherever you install it. So you can just deliver this installer wherever the end user installs it, whether in the default location or somewhere else. That will expand to the right place. And then in this case, we gave Windows-specific options saying that we want a shortcut and we want a window menu. So we also hope to provide a tool provider option. That's something that's used by other tools like Java-C, Javadoc, to allow you to, from a program, usually from some sort of build tool that you want to integrate without having to exec a new process, it allows you to call into the jpackage tool. So in this case, we first find the jpackage tool, and then we use it in a way that looks a whole lot like the previous shell script example. You pass in the list of arguments as strings to that run function. So this next example is one, and I'll run, like I said, the first several of these I'll show. This one is taking, again, a non-modular jar with an application and using a third-party library. In this case, I chose one near and dear to my heart, JavaFX. And so we have a module path that we specify with the jmods, JavaFX-jmods-13, which you can download. And then we specify which modules we want. Some of them are JavaFX modules, the first few there, and then we also say, and we need java.logging. So that's what my non-modular jar, the ensemble8.jar needs. And then, again, we specify that we want a shortcut. So this one is the same example, only now we have a modular app. So what's different here is that in addition to putting JavaFX jmods13 on the module path, we also specify that we want the input directory to be on the module path, because that's where my now modular jar file containing my application lives. And then we specify the -- module parameter so that it will produce a launcher that when you double-click on that, it will know to launch demo.parallel.main as the class in the Mandelbrot module. And then finally, I think this is the last, no, it's not the last Windows example I have. I've got a couple others. This is with a custom runtime. We've got a couple examples of showing a custom runtime. So by default, because none of the previous examples specified this, it will take whatever JDK you run jpackage from. So if you download JDK 14 and you run that and you say jpackage, whatever, it will use that JDK 14 image as your runtime image. Well, there may be times when you don't want to do that. You may want to customize it in some way. Maybe because you want to run jlink first yourself, because you want to use your own custom set of options that jpackage doesn't provide directly. So you can run jlink yourself, which I show in the first line. to produce my JDK 14 with FX and with only the specific modules that I list. And then you would run jpackage, but now instead of specifying my module path and here's my input, you basically say, here's the runtime image I'm going to use. So my runtime image in this case is JDK 14 plus FX. And here's another example, which is actually more along the lines of what we've had a lot of people ask for, and that's, well, it's going to be in JDK 14, but how do I run a program that's built and distributed with JDK 11 LTS if jpackage isn't backported to there? And this is the answer to that question. You can say, I want to run my application with JDK 11.0.5 or whatever JDK you choose to specify there. And not all applications have to be graphical-based applications. You can do console applications. In this case, the only option we had to add is --win-console. And that's because without that, for those of you who run Java applications on Windows, it's the difference between whether we use Java or Java W as the base for the launcher. And then we have the same thing on the Mac, so I think I'll skip over a couple of these pretty quickly. This is the same as the first example, but for Mac. The difference here is we're doing a PKG installer. This is a non-modular app, again, Ensemble 8, just showing it for the Mac, so this is the same as example number 3. This one's a little bit different than the earlier ones in that we're showing an example of a modular application without a third-party library using Swing. And this particular one, the second version there is the more interesting one. And that's that we're jlinking something where now my jlinked custom runtime doesn't just contain the runtime modules and the library modules I need. It also contains my application. So my JDK in this example includes all of the JDK classes that you need, plus it includes Notepad, which is our application. And so everything is right there inside. There's no additional jar files needed. And so you'll notice there's not even a -- input directory because we don't need anything. By the time jpackage gets it, all it needs is that runtime image. And so that's the only interesting piece there. And then this is the same example for Mac that I showed earlier running JDK 11. On Debian and RPM, we've got a few additional options because they have a very sophisticated package management scheme, and we want to make sure that application vendors can hook into that. So this shows an example of using a couple of the Linux-specific ones as well as a Debian Linux-specific option to specify the Linux package name as well as the maintainer field for Debian packages and the app category, which shows where it goes within the application layout. In the case of Debian, you have a menu option that shows that. And then this is the same thing for Red Hat Linux. Again, we have mostly same options as before, and highlighted in red are the ones that are specific to Linux. So now I think I'll show a couple of those demos. Make sure that can be seen. Okay, yeah. I think I'll hide this so that it doesn't get in the way. All right, well, hopefully that's big enough that if you remember back from the first demo slide I showed, or first code example slide, that's exactly the content of that slide. And so what we're doing is we're running jpackage, we're telling it to produce the exe, and it's going to eventually produce a .exe installer. Let me move that over here. And the thing that's taking the most time here is running the Wix tool set to actually produce the MSI installer, which will then get bundled inside the exe installer. And once that's done, you'll see there's a swing set to demo and then the version number, and it's a .exe file, so I can double click on that. I haven't done any code signing with this or anything, so it comes up with a scary Microsoft dialog that I, of course, accept because I don't really ever read them very carefully. And once this is done, we have a swing set to icon here, and also there's something in the start menu, swing set to demo. And so I can either double click it on the start menu or I can go right to there. And you can see it brought up the splash screen. I'll run it again so you can see it. And you can ignore the fact that there's a bug in the splash screen there where it comes up briefly as the wrong size and then ends up coming the right screen, or the right size for the screen. That's because I'm running high DPI mode on this. And so this is just the standard swing set 2 demo that most of you have probably seen. Oops. All right, and then we're going to, so I'll run the ensemble demo. And so this is very similar to the other one, but this shows using the main thing to highlight here is it shows using the add modules. Oops. Yeah, that one right there. Okay, now it's done, so we'll run that. And scary dialog again. And I'll go ahead and let it run, and it will install right there. So this time I'll just run it from double-clicking. It doesn't matter, it runs the same way. And then we get the ensemble demo with all the things it can do. So now I'll show the modular application. So the main thing here is to note that the application itself is in a module, and so we don't have anything on the class path, just the modular jar that ends up getting jlinked into the application. So this might be a good time to show you also, while we're waiting for this, the layout of what goes in there. It looks just like what you would do if you ran jlink. But so that's what the layout looks like on disk. So it's in program files, swing set 2 demo. So by default on Windows, it's going to put it in C:program files unless you choose somewhere else to put it. And then it'll use the application name after that. At the top level of that, we have an exe, an icon if you need it. In this case, we bundled in a Java icon, which is the default, the Duke icon. And then it has an app and a runtime directory with support. The app directory just has the jar file, so that is the actual executable jar file right there on the class path. And it has a configure file which tells how to launch the program. And then it has the splash screen because we added that in there. And then the runtime directory I won't show you, but all that is a standard JRE. The one that jlink produces. And so now if we run this one, so this will also install modular FX application and runs the same way as a non-modular one. And there it is in the start menu, and so then we can run this Mandelbrot program. And I want to run the one that shows running to a different JDK. So if I run this, what I'm doing is I'm creating, so I had already created the application, which was JDK version, and I made sure to compile that with JDK 11 because I want to distribute it with JDK 11. And now I'm running jpackage specifying as the runtime image JDK 11.05. So while we're waiting for that, if I so in the input directory, which is what I'm passing into jpackage there, is the executable jar file there, which you can't see because of the highlight colors, but it's jdkversion.jar. If I just run it with the, oops. So if I just run that with the same JDK that I use jpackage, it's going to identify itself as JDK 14. And sure enough, in fact, 14-jpackage, because it's a special build of jpackage early access, is what we're running at. But that isn't what we want, so I hope what I've done here is I've distributed a package, an executable, or built one that we're going to distribute that has JDK 11 baked in with it. And so when I run this one, it should say JDK 11. So Oracle Corp 11.0.5 LTS. And so that's what we wanted to do there. And in the interest of time, I think I will skip running the console demo. And then, let's see. Trying to see if there's any other demo. I think I'll skip the rest of the demos in the interest of time. So we'll go back from there. Okay, so the status of jpackage is we plan to deliver this as an experimental or incubating tool in JDK 14. When you run it, it will warn that it's not final, and so you'll get a very clear error message, warning message saying that this is not a final tool, it's incubating or experimental. But otherwise, it runs just like you'd expect. So there's no difference in the way it will behave when it's final. The main reason that we're making it non-final is to allow for the possibility of getting more feedback. Because we've had some limited feedback with our early accesses, but we don't know for sure that we've got everything we want or covered every case. And we want the ability to do what we've already had to do during the early access, which is make some slight incompatible changes to the command line interface. We don't expect anything big. We're not even saying we're going to break anything, but we reserve the right to make those small incompatible changes. The latest jpackage that's out there on the net, and I'll show you the URL later, is it has all of the planned interface changes, so all of our API in the form of command line options is there and we believe stable. We'll probably release one or two more early access builds, and we hope to propose it to target to 14 sometime this month and then get it in to JDK 14. At that point, it'll become part of the regular early access builds. And so these are our various links that would be useful to go take a look at if you're interested in learning more. There's the JEP link. Our early access builds, as I mentioned, you can go get the build that's out there right now, and then any other new builds that happen before we integrate it in. And then once it's integrated, just go get it from jdkjava.net/14 at that point. And we're accepting bugs. You can actually file a jpackage bug, even though it's early access, in bugreport.java.com with the tools category in the jpackage subcomponent. And then the mailing list this is being discussed on is core libs dev. In the future, we expect to move this from the experimental stage to the final stage, probably in JDK 16, because with the overlapping fast release cadence, if we tried to do it in 15, we don't think we'd get enough time between the GA of 14, which is when early access developers will kick the tires earlier, but a lot of people won't use it until it's final. And so from the early access of 14 until we have to finalize 15 is only about a little less than 3 months. And so we'd rather shoot for getting some feedback, improving it a little bit in 15, and then making it final in 16. And then adding in some different features, the first two of which were ones that were in the Java packager tool, although they had some limitations. And so in summary, we think jpackage is a good direction. It takes the place of the old JavaFX packager, Java packager that we used to distribute. And it isn't the whole deployment future, but we believe in the new model of you distribute everything as one app. It's a very important key part of that. Our support right now, we support JDK 11 and forward, so you can't take this and bundle a JDK 8 app. For that, I'd recommend just downloading the Oracle JDK 8 and using Java Packager. And we need feedback. So any of you who are interested in using it, please go download the early access and give us feedback. And I think we have about 1 minute for questions, if there are any. Yes?
Do you support some requirements based for the Red Hat RPMs that you define some kind of dependencies during the packaging process?
Yes, we do. So by default, we'll go look at all of the pieces of the JDK that you use and anything else that you use for native package, and we'll do dependency checking. And I believe you can also add your own dependencies in there. Yeah, I figured if not, then that's something we would add. Okay, one last question. It tells me time's up, but if there's one last question, I'll take that. And then, well, yes, one last. Go ahead.
Do you have any plans to support Brew on the Mac?
Not directly. What we're doing is doing just the packaging piece. So that would also be a good question. Do we plan to support anything related to the Linux repositories? And I think the answer is no. We'll build a package that then could be used in conjunction with that, is the current thinking. All right, thank you. So we're out of time.